Okay. To recap, since I started the recording a tad late, we are solving quadratic equations by factoring, which we have already covered this year before the winter break, but it's a big part of this unit on quadratic equations and quadratic formulas, so we're basically redoing it for the most part. So, anyone know what a quadratic equation is? What makes something a quadratic equation? So it has three terms? No, it can have, the problem we worked on Friday had less than three terms, right? And they were quadratic equations. So first off, in order for something to be an equation, what does it have to have? Equal sign, very good. To make it a quadratic equation, the variable on the exponent has, the biggest variable on any exponent has to be what? 2, that's right. So it has to have a degree of 2. So a quadratic equation is an equation with a degree of 2. An example of one of those would be x squared plus 6x plus 9 equals 0. Another example could be x squared plus 12 equals 0, just so you can see that you don't have to have 3 terms. How many solutions can a quadratic equation have? Very good. 1, 2, or 3. I didn't even get to throw out any of my ridiculous numbers that I was going to throw at you. 1, 2, or 3. 1, 2, or no solutions. Did you say 3? Oh, you said 3? Oh. 1, 2, or no solutions. But your core was 2/3 of the way right. 1, 2, or no solutions. It can't have 3 solutions. Now, we have solved equations that had 3 solutions before because we have factored out a greatest common factor. And then what we had left was a quadratic equation. But if it's a quadratic equation that can only have 1, 2, or no solution, we call the answer to the solution. What's the other 2 things we said? We talked about this on Friday. What's the other 2 things we can call the answer or the solution to a quadratic equation? Zeros and roots. Very good. When you're solving using the square root, I guess maybe that's where the root name comes from, right? You take the square root of both sides, like we did in Friday's assignment, it would be, the answers would be the roots. Okay. We're going to call them zeros today because that will help us remember one way to solve them. We're going to be studying everything equal to zeros. We're going to call those zeros. Remember that the solution to a quadratic equation is the x value when y is 0. So it's either there's a point that would cross the x-axis, and those points always are going to have a number for x and a 0 for y. It could be 0 for x and 0 for y, but other than that, there's always a different number for x, right? So x-intercepts always have a 0 of y. So today we are going to be solving by factoring. We're going to be solving quadratic equations by factoring. And not all quadratic equations can be solved by factoring, but the ones we're going to work on today can be. So if you still have your chapter 8 notes, this is where we did, we several solved equations, quadratic equations, with different strategies depending on which form they were in. So if they were in a squared plus bx plus c equals 0, that was one form. Oh, I forgot my accent. Ax squared. X squared plus bx plus c is a different form. And we factored the 4-term polynomials by grouping, but we learned that so we could factor these expressions. So to solve by factoring, 3 easy steps. Easy to remember how to factor. First thing we're going to do is set the equation equal to 0. You writing what I'm writing down? Or more what I'm uncovering today? Then factor the side that is not 0. Then we're going to set each factor equal to 0 and solve. This is not the hard part. The hard part is remembering how to factor. We did a lot of factoring this. I'm hoping I'm gonna go through it with you pretty quick. I'm not gonna write steps out for factoring again. But if you need the steps written out, you have them in your notes. I think 8-4 was factored by 13, then we did 8-2, 8-3, and 8-6. So those can help you if you want the steps actually written out for factoring again. We're going to start by factoring this quadratic equation. X squared plus 6x equals -9. Our first step says to get the quadratic equation equal to 0. What can you do to get this one equal to 0? Diane? Add 9 to both sides, that's right. Because when we add 9 to -9, we get 0, and that's what we need, right? So we can do whatever we need to as long as we do it to both sides of the quadratic equation, or any equation. So now we have a quadratic equation in this form, x squared plus 6x plus 9 equals 0. This is actually one of our special quadratic equation forms. This is a perfect square trinomial. If you remember the shortcut for that, that's great. You can use the shortcut. I'm going to show you how to do it the long way. The long way for these is not that long. If they're factorable, and yours are going to be factorable in today's assignment, it will factor into 2 binomials. We are going to check to see if we can find 2 factors of 9 whose sum is equal to 6. 3 and 3. So positive 3, positive 3. So plus 3 and plus 3. What was in our first spot here? Okay. So remember, these two things are being multiplied to equal what we started with. Basically some version of dividing, right? Now, the next thing it says to do is to set each factor equal to 0. Well, our factors are identical here, so I only have to set one of them equal to 0. Does that make sense? I do the same thing no matter what I put in. So x, if I do it, however many times I do it, that's what makes it a function. If I could do this over and over again, I'm going to get the same value. I'm going to get -3 every time I do it. So -3 is the solution to this quadratic equation. If we plug in -3 here, the left side will equal the right side. Let's look at a problem that looks like your first problems on your worksheet today. You can flip your page over and we'll do some notes in the back. So let's do our next example. Let's say it's already factored. So our first step says set the quadratic equation equal to 0, and it already is. The next step says to factor the side that's not 0, and it already is, right? It's given us two parentheses, binomial times binomial. So these are the ones we like. All the work is done for us here. All we have to do is recognize what the factors are and then set them equal to 0. So what am I going to set equal to 0 here? Very good. So it'll be x plus 3 equals 0 and x minus 2 equals 0, and then we're going to solve those. For x, I realize I didn't take roll. I'm doing that real quick. Right. So, absent, I have Brooklyn, Annabelle, Kayshawn, Danielle, and Sakiria. Didn't count anybody absent that's here, did I? Also, Severian, is Severian here? No, okay, I missed him. Okay, so what do you get for your solutions, Brandon? -3 and 2, very good. So subtract 3 from both sides here, you get -3. Add 2 to both sides here, and you get 2. So our solutions to this quadratic equation are -3 and 2. This equation has 2 solutions. You've got another one that looks something like this. 3x times, let's say, x plus 4 equals 0. Already factored. What are the two factors here, Trinicia? What's being multiplied here? Jaden? Isn't this 3x times x plus 4? Right, so our two factors are 3x and x plus 4. 3x is one factor, set it equal to 0. X plus 4 is the other factor, set it equal to 0. And then we're going to solve. We're going to undo, this is 3 times x, right? We're going to undo multiplying by dividing. And we know now that one of the solutions is x equals 0. We're going to undo the adding by subtracting. And we know that the other solution is -4. So if we give our answer in set notation, our solutions are -4 and 0. Remember, 0 is not a no solution. 0 is a value, right? It's possible that you might have a quadratic equation that you solve that has one answer, and that answer is 0. That is not the same as no solution. All right, we're going to do a couple of examples. It's really important that you pay attention to the form of the equation, what form the equation is, because your strategy depends on that. And I get in a rush at the end of first period, and I did not use the right strategy, so I couldn't factor it. When we took our first test on factoring, there are sometimes expressions that you can't factor. For our purposes on these quadratic equation tests, and we'll see for sure when we do our reviews, but we're not going to have any. If it says, if it gives you the factors, we're going to solve by factoring. Actually, you know what? I don't think you have to worry about that, because when we, nope, you won't know quadratic formula yet. So anywho, you should be able to factor or use the square root method to solve all of these quadratic equations that will be on your next test. We're going to do another example. Let's do t squared plus 3t minus 18 equals 0. So once again, this is in the form x squared plus bx plus c equals 0. That's not a 6, that's a b. That's the form, that's the strategy. That's how we know what strategy to use here when we're factoring. So the very first problem we did today, we used the same strategy. What's the first thing we should do to factor this side of the equation? What do you think? Any idea? Add 18 to both sides? Now, if we have 3 terms, we want to keep everything set equal to 0. If we have 2 terms, we might want to solve using the square roots, and so we might use that strategy just like. If there was no 3t there, it would be a great idea to add 18 to both sides and then take the square root of both. Here, if we have a trinomial that has an a of 1, right, so the number multiplied by that t squared is 1, we're always going to have 2 binomials as our factors. Yep. Yeah. So the product is negative 18, the sum is 3. Say it again. Alright, so we're looking for factors of 18 now. What are the signs on these factors going to be? Perfect. One's going to be negative, one's going to be positive. So 1 and 18. When you have a negative, or just basically you can subtract them to see. Perfect. 6 times 3 is 18, and 6 times negative 3 gives us negative 18. So 6 plus negative 3 is a positive 3. So plus 6 minus 3. Now we just put those over here. Plus 6 minus 3. What was in the first spot here? Yes. It doesn't really matter. I think it says the smallest to biggest up on the number line, but it's not right or wrong. Alright, so now we have factors. Now we put them equal to 0. So if they're both in parentheses, it's easier to recognize, I think, than this last example. Last example is a little bit more confusing because this is not in parentheses, but it doesn't matter. It doesn't have to be in parentheses. So here we have two factors, set them equal to 0, and solve. You should all be able to solve these 1 and 2 step equations pretty quickly. And so the solutions to this quadratic equation are negative 6 and 3. Alright, so next strategy is a little bit more challenging, just a little bit more work. We're going to review it. We did work on these a lot. Y'all caught up with me? Okay, so our next example will be 8k squared minus 2k minus 3 equals 0. So this is in the form of ax squared. So a is not equal to 1. If a is greater than 1, we've got to factor by grouping. We're going to split the middle term and then factor by grouping. So this is where our first step is a times c. And this is what I messed up on the word problem. I was trying to do the number 24 with them, and I was in a hurry, and I forgot my a times c. So if this number is not 1, you have to remember to multiply a times c first. What is a and c in this example? Fatima? Negative 3, yes. So 8 is a, and negative 3 is c. So when we multiply those, we get negative 24. We're using our Berry method x here, but this is not going to be our factors. What we're doing now is we're rewriting this trinomial into 4 terms. The first term stays the same. The last term stays the same, and we are going to get 2 terms that will equal negative 2k. So our product has got to be negative 24, and our sum has to be that negative 2. Can you think of 2 factors that have a difference of a difference of 2? If you multiply them together, they give you 24. What do you think, Kendall? Can you give me 2 numbers multiplied together to get 24 that have a difference of 2? We know 24 is going to be negative, so one's going to be positive, one's going to be negative. So start listing them if you're... It is. So these are the factors. We need 1 positive and 1 negative. These have a difference of 2. So negative 6 and positive 4 equal negative 24. And positive 4 plus negative 6 equals negative 2. And that's what we need. So plus 4 minus 6 plus 4k minus 6k. Together those equal negative 2k. Sounding familiar, Jaden? Remembering that? Does that sound familiar, Ulrich? Okay, so now we factor by grouping. To factor by grouping, you get a group. When we're factoring 4 terms by grouping, we're always going to wind up with 2 binomial factors. How are we going to find our first binomial factor? Do you remember? Akira, how do we find our first factor? Very good. The GCF is the first one. What is the GCF of 8k squared and 4k, Brandon? K is part of it. Is there a numerical part? 2 is a common factor, but not the greatest common factor. So let's see. 1 and 8, 2 and 4. Those are the factors of 8. Also have 4 here, right? So 4, 1 and 4, and 2 and 2. So the biggest common factor is 4, right? So it's going to be 4k. Does that make sense? What's going to be the greatest common factor of the second group? Anson, can you help me? What's the greatest common factor of the second group? Say it again. 3. Very good, 3. But are we going to use a positive or a negative 3? Yes, if this is negative, we make this one negative. How do I find my other factor? Do you remember how we find our other factor? Tunisia? How do we find our second factor here? Divide this first group by the 4k, that's right. The greatest common factor of that group. So 8 divided by 4 is 2, k squared divided by k is k, it's a plus. 4 divided by 4 is 1, and k divided by k is 1. Multiply those together, you get 1. So our factors, 4k minus 3, 2k plus 1, set them both equal to 0, and solve. Remember, quadratic equations can have decimal or fraction answers. That form doesn't matter. This is a 2-step equation. 4 times k minus 3. We undo the minus first by adding 3 to both sides. So 4 times k equals 3. We undo the multiplying by dividing. And our first solution is 3/4. 2 times k plus 1, we undo the addition first. Subtract 1 from both sides. We have 2 times k equals negative 1. Undo multiplying by dividing. And k equals negative 1/2. So 2 solutions, negative 1/2 and 3/4. Other than scratch 22, so just mark that one out. And we're going to do 24 together. This is the one that I got in too big of a hurry. Getting in too big of a hurry, not thinking through the criteria you need for something is a big deal in these problems. So we're going to start with a rectangle. Mrs. Zimmerman. She is not here today, or not in my class. Okay. What do we know about the rectangle? Let's look at the problem. It says leaning is cutting a carpet for a rectangular room. There's a red carpet evidently. The area of the room is 324 feet squared. The length of the room is 3 feet longer than twice the width. What should be the dimensions of the carpet? So first off, they give us the area. It's 324 feet squared. And it's a rectangle, so we need to be thinking, what is the formula for the area of a rectangle? What's the formula for the area of a rectangle? Anybody remember? What is the area equal? Length times width, that's right. It tells us here that the length is 3 more than twice the width. So if this is the width, then the length is 3 more than 2 times the width. Does that make sense to everyone? We know this is the width. It tells us that the length is 3 more than twice the width. To find twice the width and add 3. Does that make sense, Peyton? Okay, so now we need to write an equation. We know the area is 324. And we know it's equal to the length times the width. So the length is 2w plus 3 times the width. I could have put the w first. I probably would if I were doing this on my own. Now, we're tempted to try to set these equal to 0 and solve, right? But we can't do that because this equation is not equal to 0. So before we can do anything like that, we are going to get this equation in standard form. So to do that, we need to get rid of these parentheses and kind of start over. So w times 2w is 2w squared. And w times 3 is 3w, and I've kind of switched my sides around. I'll put my constant on the right. So, to solve by factoring, we need this quadratic equation equal to 0. So we had to do some work to write the equation before we could even write it in standard form. To write the equation based on what they tell us about this rectangular surface. So what are we going to do to get this equal to 0? Diane? Yes, take 324 from both sides. So now we have 2w squared plus 3w minus 324 equals 0. This is the starting first period. I tried to just factor it using the varying method, but we can't do that because this equation that we've written is in this form. It's got an a that's greater than 1. And so we have to do our a times our c and split this into 4 terms, right? So we're going to have, this term will be the same, this term will be the same, but we're going to split this into 2 so we can use our factor by grouping strategy. So what is our a and what is our c? And we're looking at this equation now, because this is in standard form now, and that's the only way we can identify a, b, and c. So what is our a, our b, and our c here? Gladys, can you tell me what our a is? 2. And, 2. And what's our b? Our b is 3. And this is our c. Negative 324, right? So a is 2. We don't need our b for these problems. So this is the part I messed up. So a times c equals negative 628. Sorry? Oh, thank you. Negative 648. And so now we're going to use our little very method triangle. Our product is negative 648, and our sum is what? Positive 3, right? So there's some big numbers. So we're going to start, I'm not going to list every single one. I'm going to kind of play with that a little bit. So I did figure out I had done something wrong because I kept trying to factor using the 324, and there were no factors that would give me that middle number. And finally, one of the students in first period, he was already working on his homework, caught my mistakes, and that's great. I love it when you guys catch my mistakes. But that's also, I tell you this, so if you're on taking a test or doing your homework, and you try and you try and you try and you can't get them to factor, and they'd ask you to solve this by factoring, maybe you picked the wrong strategy. Maybe you forgot to do something like I did. That's what I'm kind of going for here. So here we're looking for factors of 648. If you subtract them, you get a positive 3, remembering that 648 is negative, so our factors, one will be positive and one will be negative. One's going to be positive and one's going to be negative. So I'm going to look on the calculator, or play on the calculator and see if I can find two factors. 648 divided by, I know 3 will come out of it, and 6 will come out of it. I'm going to divide by 6, and that's 108, not nearly close enough. Did I do 12? 12 and 54. Ooh, if I take 628, so I'm just trying to find factors, 628 divided by 24 is 27. What's the difference between 24 and 27? Oh, I did 48 on my calculator, sorry, thank you. I read the wrong thing there, but I did do it right on the calculator. Y'all can double check me if you want. But 24 times 27 is 648. So if I need a positive 3, my 27 is going to be positive and my 24 is going to be negative. Does that make sense? All right, so now we're going to add I don't want to add 27, I want to subtract the 24. It doesn't really matter, but that's what I want to do. Plus 27W. If I add those together, I should get this middle term, and I do. So now I'm going to group. Now I'm going to follow my directions, my steps for factoring by grouping. Greatest common factor of each of these groups is 2W. What's the greatest common factor of these two? I don't even, 27, right? Because when it, oh no, I lied. Let's see. 324 divided by 27. Yes, it is. It is 27. And it's a positive, so that's a positive. So our other factor we find by subtracting the greatest common factor here. So 2 divided by 2 is 1, W squared divided by W is W, minus 24 divided by 2 is 12. So now we have our factors, now we're at the easy part, right? Two factors, and set them each equal to 0. Two times W plus 27 equals 0. What's the first step to solve this equation? Do we undo multiplying or adding first? What should I do first to solve this equation, Naya? What should I do first to solve this equation? Yes. And then we're going to divide both sides by 2. So W equals negative 27 halves, and we can leave it just like that. Add 12 to both sides, add 12 to both sides. The width equals 12. So we have two answers here. Can length be a negative number? So we have a length of negative anything. So when you have real world problems, you sometimes have to kick out one of the solutions, right? So now we know the width is 12, and now we need to find the length. Well, we wrote our equation. The length is 2W plus 3. So the length is 2W plus 3, so we can plug in now. We know that the width is 12, so 2 times 12 plus 3. So our length is 27, and our width questions on that? Alright, you can scan and submit your notes. If you did not scan and submit your homework and notes from Friday, you can do that. Need me to go back to someplace, Brandon? Need me to go back anywhere? Need me to go back? Tell me when to stop.